Good morning, everyone. If we can settle in. Before we get started with this next talk, just to give you a heads up, I'm still waiting on confirmed details of the talk, but there has been a slight change coming up later on next door. One of the talks has changed. There will be a new Django talk. The web schedule is being updated as we speak, and I'll have some confirmed details hopefully by the end of this session, so I'll let you know what's happening there. So on to the first talk in this session for the day, Web Server and Bottlenecks and Performance with Graham Dumpleton, who has been the author of Mod WSGI, a pretty instrumental piece of code for Python, and he's also a member of the Apache Software Foundation and the Python Software Foundation, so very active in the community, and we're pleased to have him to give us this talk this morning.
Thank you. This is actually a fill-in talk. Someone else's talk couldn't happen for some reason. I don't know why. I guess most people might have realised that because I have done this talk before at PyCon in the US, SciPy in Sydney, and also a user group in San Francisco. So it's possible you've seen the video. Some people have seen the video, and that's why we've got a small crowd today. But it doesn't matter. The slides are already up on SlideShare, and my slides from yesterday's are now up on SlideShare. I finally managed to get them up by doing it from my room. And if you feel if you want to check up with how I do on this talk, you can always go back and watch the PyCon video from when I did it last time too. So before we talk about web server performance tuning, it's important to step back and look at the bigger picture. Although newbies especially have an obsession with trying to find that fastest web server they can, reality is that things are a little bit more complicated than that. Systems have many moving parts. The actual per request latency introduced by a web server is very small in relation to the time spent in other parts of the system. As far as a user is concerned, the main delays they will notice are those resulting from how long it takes their web browser to render the page returned by the web application. This will be followed up by network delays when talking to the web app and when grabbing down static assets from media servers or content data networks. The time spent in the web application is therefore a small percentage of the time as perceived by the user for rendering a web page being served. Any time delays introduced by the web server will be a much smaller percentage again. Steve Sunders summarises this disparity between front-end time and web application time in what he calls the performance golden rule. This is that 80 to 90% of end-user response time is spent in the front end. If you're after an easy win for improving end-user satisfaction with your website, the front end is actually where you should start. So although the big immediate gains may be won in the front end, the web application still represents lots of opportunity to further reduce response times through means other than fiddling with the web server. Improvements can be had in the application code, but also in databases or back-end services used by your web application. So is running benchmarks on web servers a complete waste of time? The answer is yes and no. The sort of benchmarks that are usually published on websites to compare web servers usually serve little value. They generally only serve to give newbies a false sense of security over any decision they make as to which web server they choose to use. Worse is that people forever reference these benchmarks as the gospel truth when they can be far from it. The main reason that typical web server benchmark is useless is that it tests only a single, narrow, idealised use case. Web servers are implemented using different architectures and using different code. You're better off choosing a web server that you believe has the features you require and then use benchmarks to help explore the behaviour of that system. Often the documented benchmarks you find are nothing more than a hello world program. The test then consists of running it at a maximum request throughput with some arbitrary number of concurrent users. This does not mirror what real traffic a public-facing web server would receive. It certainly doesn't show what causes the server to fail as load increases, just that it will. What should you test then? There are many different use cases one could test, and how anyone performs can be dictated by the architecture of the system, how the code was written, and how the system is configured when the test is run. The more interesting tests are those which deliberately go out to trigger specific problems. This is because it is the corner cases that are usually going to cause an issue rather than the typical use case. What sort of factors can come into play and affect performance? These are varied and can arise from the hardware or virtualized system being used. They can derive from the configuration you use for the specific web server, but also can be influenced by how the Python language interpreter works. To make it hard, these can all interplay with each other in unexpected ways. Some things can be out of your control altogether, such as the type of web browser and what type of network the traffic between you and the user has to traverse. Very few published benchmarks try to account for these issues in a realistic way. Requirements as dictated by your own web application or how you decide to architect your overall system can also contribute, such as whether you try and use the same server to serve up static assets. To illustrate how some of these different factors can come into play, I will go through a few specific use cases that present issues in practice and where possible relate them to these factors. These include memory usage of processes versus threads, impacts of long-running requests, and restarting of server process and startup costs. A simple place to get started is memory usage. This is always a hot topic of contention with benchmarks. It isn't hard to find people claiming that Apache is a big bloated memory hog. This benchmark in particular is representative of a poorly chosen Apache configuration. Of course it will use more memory if you configure it to have 1,000 threads. If servers aren't set up in a comparable way, you can hardly expect it to be a fair comparison. Actually, estimating the overall amount of memory used is not a difficult exercise. It's after all a simple formula taking into consideration the number of processes, the base memory used by the web server, memory for each additional thread, and the application itself. Things get more complicated when one considers per request transient memory, but ignoring that, one can easily visualize what you're dealing with. In short, adding more processes is going to see memory usage grow quicker than adding more threads to existing processes. Although some of that per process based memory usage is the web server, the majority of it will be, in the end, be your fat Python web application. To blame a web server for using too much memory is plain silly, when your web application could be using up to 50 to 100 times as much memory. The issue is really about what configuration you choose to set the web server up with. What usually happens is that people will blindly use whatever the defaults are for a server. For fat Python web applications which use a lot of memory, this can be disastrous. Apache with its pre-fork npm can, for example, dynamically create up to 150 processes. That is potentially 150 copies of your fat Python web application in memory. So of course it's going to use a lot of memory. Those servers which generally seen as faring best as far as memory usage are those whose default configurations use only a single process and a single thread. Guess what? If you were to configure Apache that way, then the amount of memory it uses will not be much different. So granted though with Apache, it does help to also strip unneeded modules out of Apache that you don't use to really get the best from it. So don't start things off by using whatever the default processes, threads, configurations are, especially if looking at memory usage. Do so and you can easily get the wrong impression. Also don't pick arbitrary values when you have no idea whether it's reasonable. At this scale, a configuration of 1,000 threads as used by that benchmark will not even fit on this chart. It's sort of like over there in the next room somewhere. How many processes and threads should you use then? The total number of threads across all processes is dictated by the number of overlapping concurrent requests. How much overlap there is depends on response times and throughput. Processes are preferred over threads, but constrained by memory you have available. The optimal number can also be dictated by how many processes are available on the system. Unicorn, for example, recommends you use 2 to 4 times the number of processes as you have CPU cores available. One can get a feel for how many threads you will need by looking at thread utilization. That is how much do the requests take up of the potential capacity. In this example, by adding up the green areas representing the requests coming in over time, we have a thread utilization of about 2. This means that if all requests were serialized, we would need only 2 threads. Requests don't arrive in such an orderly fashion though, so we do need more threads to ensure that they aren't delayed. Because response times are generally quite short, it's actually surprising how few threads you can get away with. If the number of threads is too low and response times or throughput grows though, then the thread utilization will increase. Eventually what happens then is that requests will start to back up as they wait for available threads, and queuing time will increase. This will add to the delays that end users sees in their total page load time. If we add processes rather than threads, we can delay the onset of such problems. The reason that processes work better is that the Python global interpreter lock effectively serializes execution within distinct threads of a single process. Adding more processes, though, obviously means more memory. This has got nothing to do with which server now, and a choice you make which is going to be bound by how much memory you have available. If you are memory constrained, finding the right balance and what you can get away with in order to still reduce memory usage is a tricky problem. It is all made harder when you have no idea what is going on inside of your web application. If a web application has a heavy bias towards CPU-bound activity within the process, then you are forced towards the direction of needing more processes because of the issues with the GIL. If your web application is making lots of call-outs to back-end services and so threads are blocking and waiting on I/O more of the time than not, you can get away with using more threads because the threads aren't competing as much with each other for use of the CPU within the same process. If you have no idea what your web application is doing, this judgment is going to be a hit and miss affair as far as tuning the process's threads balance. To make such judgments even harder, you also have long-running requests to contend with. These can arise due to issues in your own code or back-end services, but also due to how much data you are moving around and how slow the HTTP clients are. The basic problem here is that a long-running request, because it ties up a thread, will reduce the maximum throughput you could achieve during that period of time. The unpredictability of request times means you need to always ensure you have a good amount of extra capacity in the number of processes threads allocated. Don't provide sufficient headroom, and when a number of long-running requests coincide, you will suddenly find thread availability drops, requests can start backlogging, and the overall response times as seen by your user will increase. Where your application code or back-end service is slow, you obviously need to work out why. Sometimes issues can come from places you least expect them. For example, especially with Django, watch out for how long PostgreSQL database connections take. One thing you can consider in this case is a local external connection pooler, such as pgbouncer. If you're using Apache ModWSGI or Unicorn, stick Nginx in front of it and proxy requests through to your WSGI server. This will make your WSGI server perform better as you will be isolated from slow HTTP clients. The threads in the back end will be tied up for less time, meaning lower thread utilization, thus allowing you to handle a higher throughput with less resources. You can also offload tasks such as static file serving to Nginx, which is going to do a better job of it anyway. When introducing a front end, do be careful though of the funneling effect, especially if the number of concurrent requests that can be handled reduces at each step. If your web application backlogs, users may give up, but requests are still queued up and have to be handled. Your web application wastes time and may have trouble catching up with the backlog. It is perhaps better to set up servers so requests time out with a 503 before getting to your web application if you can. Worst case scenario here is complete overload, where the server never really recovers for an extended period or until you can shut down the server. Request timeouts within the web application, where supported, can help a bit, but only to throw out long-running requests. As already mentioned, you really need to stop those requests getting to the web application if there is no longer a point handling them. Options here vary and solutions available to avoid it aren't always great. You might actually think that doing a restart will solve a problem with backlog requests. You have to be careful here as well though. For some servers, the listener socket can be preserved, so any backlog there isn't actually cleared. Further, when performing a restart, new processes have to be created and application loaded again. This can take time and cause more requests to backlog. So choose carefully when you restart. To totally reset a system, it is better to actually do a full shutdown and clear out the whole backlog. For fat Python web applications with a large startup cost, server configurations which allow for auto-scaling can also compound problems. When under load, you get a further throughput spike. The server can decide to start more processes. This slows the system down temporarily, causing backlog, and if it takes a long time to start processes, the server could decide to start even more processes, increasing system load again, blowing out memory and overloading your whole system. To avoid unexpected surprises, you're better off starting up the maximum number of processes you expect or require or can fit in available memory with your web application loaded. Ensure you preload your web application when processes start and not lazily when first request arrives. Do everything possible to keep the processes in memory at all time. Avoid restarts, especially don't use options to restart when some maximum request count is reached. Because the suggestion is that you should pre-configure the server to its maximum capacity at the outset, it does limit the vertical scaling you can do, at least within the confines of the same hardware. Next step, therefore, is horizontal scaling. Keep in mind the same issue about preloading. You don't want to bring on new hosts and direct traffic to them, only for the first request sent to it to be delayed while the application loads. No matter how you set your system up, if problems do arise, the only way you're going to start to be able to understand what went wrong when it does all crash in a heap is through monitoring. If you treat your system as a black box, how will you know what is going on inside? One thing is for sure, all those benchmarks you may have run to find out what the fastest web server was are not going to help you one bit at that point. Server monitoring tools, although useful, only show the effect of the problem on the overall system. They don't necessarily provide you that insight of what is going on inside of your web application, as they still largely treat your web application and web server like a black box. A deeper level of inspection is required. So when we talk about finding out what's happening inside of your Python web application, the options have sort of been a bit limited. Tools such as Django Debug Toolbar or the Python Profiler are only suited to a development environment. Sentry can be used in production to capture errors, but performance problems aren't going to generate nice exceptions for you. Your prime option here obviously is New Relic at this point. It provides the ability to monitor the front end, your web application and the underlying server. It gives you that deep introspection required to know what is going on. For me as the author of ModWSGI, having New Relic means I've actually been able to use the reporting it provides to delve quite deep into the behaviour of ModWSGI in different situations. And the results have been quite revealing. One of the areas that has helped in understanding is this funneling effects when using daemon mode that I have talked about. I'll admit there is room for improvement there in ModWSGI. It's not quite getting it right and it's causing a few problems at the moment. It's an area which hopefully I'll fix up in ModWSGI 4 if I can get the time. So summing things up, pick a web server and architecture which seems to meet your requirements. Then use benchmarks to evaluate its behaviour. Don't use benchmarks simply to try and compare different systems. Don't trust server defaults. Configure and tune your whole stack based on the results you get from live production monitoring. Use New Relic for deep introspection of what is going on in all parts of your system. So if you are doing Python web application development, do therefore consider giving New Relic a try. If you're not sure, New Relic does provide a free trial period where you can try out all the features it has. Even when the trial ends, there's a free light subscription level which is available and it still provides lots of useful information. So give it a try. The worst thing that can happen is you actually find out how bad your web application is performing.
Cool. Thanks, Graham. Have we got any questions for Graham? Russell. Can always rely on Russell.
Russ explained to me one day why he always rushes up to make the first question.
Yep, it is on my blog.
Interesting story.
It is on my blog. Come see me if you want to find out.
Yeah.
Okay, so I completely agree with what you're saying here, and I will also just throw in a free plug on your behalf. The New Relic is awesome, and it's just saved my ass so many times in the last 2 weeks. It's not funny. What you're sort of saying here is, yeah, you need to know how your application performs, and the best way to do that is to get live performance benchmarks. However, that does leave you a little bit open to oh crap moments where, hey, I'm going to deploy my new site, and you don't have live data yet because you haven't got actual users. You don't know how big necessarily your Python application is going to be when it gets deployed. Any suggestions or tips on how you could set up in such a way that you can at least get a reasonable first estimate so you don't deploy 2 servers when you actually needed 10 to supply the load that you're expecting to get?
Well, the normal way people would handle it obviously is try and do benchmarking in their staging system. And there's obviously no reason why you can't put New Relic in there to try and gauge how that's going to work. But it's the same problem, your variability of your users and the different connections they come over and the different browsers they're using does make that really hard. So yeah, there's still no simple answer for that, except the techniques which exist already.
Thanks, Russ. Anybody else? I actually have a question. It's the advantage of having the microphone. You said in one of the slides about putting Nginx in front of Unicorn or something like that for slow clients.
Yep.
Does Apache and ModWhiskey get you a similar thing because your Python is kind of running through ModWhiskey, or is it advantageous still to have something like Nginx in front of Apache and ModWhiskey?
It's still good to have Nginx in front, and the reason for this is that Nginx is async, so you don't have this problem of, if you've got a large number of concurrent requests, of having to have one thread per request. So the memory footprint's really low. And what Nginx does is that when it gets a request in and it's proxying through to a backend such as Unicorn or Apache, is it won't actually bother proxying until it's read all the request headers, and also, depending on your configuration, and I think the default is 1 megabyte, if the request content is less than 1 megabyte, it will wait till it reads all that in as well, before it even sends it through to the back end. So it's effectively got then the whole request available. So when you do send it through to Apache, it can immediately act on it because it's got everything it needs to. And this is where the advantage comes, whereas if Apache handled it immediately and you've got a slow client and that data dribbles in very slowly, comparatively to what could be fast, then you're tying up that thread. And that means you're limiting the resources you've got to handle a large number of concurrent requests. So that's where the benefit comes from. Is that waiting for all that request content to come in. Then on the way back, when you send your response back, because you've got that buffering within the socket between Apache and Nginx, it can essentially push out quite a lot immediately. And Nginx then is the one that is sort of, again, does a bit more buffering and can trickle out the response. So Apache only gets the request when it can act on it, so it can then immediately hand it off to the application and run it. And it can offload that response very quickly. So that is the benefit from having Nginx in front.
Cool, that's great. Oh.
Sorry, I'll add to that one as well. Completely agree. The other reason that's worth it, and this is in a Django context, I've learnt the hard way, but it's also true of other web servers. Nginx is really, really good at serving serving static files. So you can have your Apache thing that's actually doing the heavy lifting with the database, and it has a big memory footprint for every process that's there. And then you've got the files just being served really, really quickly out of Nginx. So the only requests that are taking up your Apache are the ones that actually need to use Apache, and everything else is just going straight out. So
yeah, and one of the other things in Nginx, which not many people would know about, is you can actually send back a header from Apache, which is an XSL redirect or something. What it allows you to do is, essentially, if you're generating a very large response, or you're having to gate access to a file via Django's authorization mechanism, so it's not a static file which is just publicly accessible, so you can't have Nginx immediately serve it up. You need to go through authentication and everything. If that file exists on the file system, rather than actually have the Django app send the file back, you can just send back this XSL redirect header to Nginx. And as long as you set up Nginx in a way that file system area is essentially a private area which only internal requests and Nginx can serve up, you can essentially say, okay, I'll let you in, I need to serve this big large response, but here it is over here, and get Nginx to serve that up as well. So you can actually do things like that as well, which is very beneficial.
That's really cool. Oh, here we go.
Yeah, thanks for mentioning that. I actually use that feature with my own hosting service, where I authenticate in the Django layer and then offload the actual sending the file once it's been authenticated in Nginx. I should ask, I suppose the typical configuration I use is straight Nginx proxying back to Unicorn. Can you talk to the pros and cons of that approach versus having Apache in the middle as well?
Apache in the middle of Nginx, Apache, Unicorn? What do you mean?
Nginx in front, Apache in the middle, and then Django the back end?
No, you just stick Unicorn straight behind Nginx. There's would be no point having Apache involved if you're using Unicorn at that point.
Okay, but I mean, you can run my WSGI, right, which effectively is doing the same things Unicorn does, as I understand it.
UWSGI?
Or the Apache WSGI module.
Oh, yeah, mod WSGI.
So, in other words, why would I want to use Apache or Unicorn instead of the other?
Okay, the thing with Apache is it does provide a lot of built-in modules for a lot of weird things. Windows, authentication, all sorts of things like that. So it's like the batteries included mentality of Python. So a lot of people use it for that reason. It does have all this existing functionality, which if you just stick Unicorn behind Nginx, you're not going to have all those extra features. The other preference people have for using Apache is that they've got system administrators who understand it. So it can be a lot to do with comfort of understanding the particular environment you're using. So there's various reasons. And these days, the performance of the different solutions, when you really get down to it, if you configure them properly, there's not really much difference at the server level, because most of the bottleneck is in your app, your databases, your problems in front-end time, and things like this. So whenever someone asks me, people ask, well, what should I use? You'll never find me saying, go use ModWSGI in Apache. My answer is always going to be, go find the one which suits your mindset of how you think and what you think you're capable of managing. Because that's more important. You know how to manage it, because a lot of people are scared off by Apache and find it so complicated, and it's very easy for them to stuff the configuration up and make a big mess. Whereas the defaults in Unicorn are actually probably more friendly. And for PyCon next year, I actually intend trying to put in a talk why Apache sucks for hosting Python web applications, because the default Apache configuration is more suited for static file handling and PHP. It's not a good default setup for Python. And when people just grab a solution and whack it in, you're not necessarily going to get the best experience from it, especially if you just use embedded mode and pre-fork NPM. So in those situations where people aren't prepared to go in and try and work out how to set up Apache properly, Unicorn is a better solution.
Okay. So it's a better naive solution, if you like.
A better?
Naive solution.
Oh, I wouldn't say naive. It's just better for those people who don't have... They just want people who want to get on and program.
Right.
People who don't want to do system admin.
Yeah. That's me, so okay.
Just on that point of the fact that Apache can be difficult to configure correctly for these different use cases, are there any resources where you can go to get a boilerplate or good example beginning configuration templates that you could start from? Because starting from the default Apache configuration and then trying to weed out everything you don't need and get it correct is pretty daunting and difficult. I mean, if baseline configuration files were provided that made it much easier, I think people would be less resistant to trying to do that themselves.
My first guidance is, do please always use what the Apache configuration is that it's shipped. I see people who recommend throwing it all away completely and then putting in just the minimal required. The problem is there's a whole lot of defaults in there which make your system secure. And by throwing it all out, it actually falls back to actually making some things a bit insecure. So for example, if you throw out all the configuration, the default in Apache is that if Apache can map a URL to your file system, it will then serve up anything. Whereas the default supplied Apache configuration files will say, well, no, we're going to say everything from / you're not allowed in there. And then it will expose certain bits. So always use the Apache one. If you're going to, because ModWSGI has two modes, there's embedded mode and daemon mode. Embedded mode is where it runs in the Apache worker processes. If you're going to use embedded mode, always use worker NPM. Don't use pre-fork NPM if you don't know what you're doing. Like pre-fork NPM behind Nginx with ModWSGI is actually going to give you the best performance, but you do need to be very careful how you set it up. So that's my first warning on that one. Now, in terms of the talk, I intend giving at PyCon. One of the things I hope to come out of that is, and I've played with it a bit already, I've got some scripts which will take Apache NPM settings and draw some nice charts. Well, I was doing it in spreadsheet actually, from once I generated the data. And it draws you a nice little chart about how that configuration behaves as concurrent requests comes in. And it quickly shows when you've picked a really bad config, because there's some certain rules you should follow in Apache NPM settings. And if you don't do it right, you can have Apache thinking, you don't have enough processes to handle a number of concurrent requests. I'll create more worker processes for you if you're using embedded mode. And then on the next iteration, because you've stuffed up the config, it'll say, actually now I think you've got more than you need, and it'll delete it, it'll destroy it straight away. So you're not getting this thrashing of processes. So there's little tricks like that, yes, which is good. And then there's sort of things hopefully I'm going to document for this talk when I'm doing PyCon next year, and hopefully have a website set up where you can go in there, plug in your NPM settings for Apache config, at least if you're using embedded mode, and it'll draw you this nice little chart with an explanation of what it means, and try and point out, well, you're doing this is wrong, and so on. So that's something I hope to do. Yeah, well, I always want to do these sorts of things, and it always comes down to time. But I figure I've got this in my head already for next year's PyCon, and I had grand ideas for this talk last year as well, which I didn't get to either. But I figure this time I'm going to try and start and work on this.
Okay, I know we had another question, but I think we've run out of time, so we're going to have to move on. If we could thank Graham, and you get.